This video illustrates how the Monte Carlo Tree Search method can be used to automatically control a car. The objective is to guide the vehicle from one lane to another in a controlled and safe manner. The main challenge is to find a suitable sequence of steering angles over time. By selecting the right steering inputs, the car can move smoothly from its initial position toward a desired lateral position on the road. The tree search method evaluates many possible steering sequences and identifies the one that best achieves the objective. A unique feature of this video is that it also shows how the search tree is constructed. Each branch represents a possible steering decision, and each path through the tree corresponds to a potential sequence of steering angles. In this way, the animation not only demonstrates the final lane change maneuver, but also visualizes the decision-making process behind it. A car is changing lanes by steering the wheel in a suitable way. The steering angle gives the car a direction of travel, which is described by the angle psi. The angle psi shows which direction the car is pointing compared with the direction of the road. In the figure, psi is negative. The goal is for the car to reach a desired lateral position without leaving the road. The car can choose between 3 steering angles, plus 2 degrees, 0 degrees, and minus 2 degrees. This means that the car can turn slightly to the left, drive straight ahead, or turn slightly to the right. The sign convention is that a positive steering angle gives a left turn.
Seen as a special type of agent. It builds a tree and uses it for action selection. The tree is only temporary. After a search, it is discarded. The tree represents the consequences of different action selections. Every arrow in the tree corresponds to an action. Every node represents a state. The blue node in the example tree here is a root node, the present state. Other nodes are possible future states. In the example here, there are 2 actions, 4 different future states. In Monte Carlo Tree Search, there are 4 phases: traversal, expansion, simulation, and backpropagation. These phases are repeated for each iteration, and after many iterations, a big tree is in place, typically with thousands of nodes. And in this final tree, there is an optimal path representing a sequence of actions. The first action on this path is the action selected.
The frame on the left represents the environment. It illustrates the car's position and orientation. The camera follows the cars in its drive direction. Information such as the steering angle and heading angle is also shown in the frame. The frame on the right shows the search tree. The number of nodes at each depth can be seen in the frame. Here, the tree contains a total of 57 nodes. The tree construction animation now begins. At this stage, the tree is small and only a few nodes deep, so the car does not move very far. There is a promising tendency. The car moves slightly toward the lower lane. In some iterations, a new node is added, making the tree larger. Now we speed up the animation to fast forward the process. As you can see, the tree is growing larger and larger. Light colors in the heat map represent nodes with good values. Almost 5,000 iterations have now passed, and the search tree is considered complete. A tree with almost 1,000 nodes guides the steering. Wonderful. The car moves as desired. It changes lanes and remains in the lower lane. The resulting steering sequence is to first turn the wheel to the right, then to the left, and thereafter keep the steering angle at 0. The problem presented here is one of many example problems described in the book Reinforcement Learning Explained. This was only a brief description. Many more details are presented in the book. Please visit the book's homepage for more information.